Assalamualaikum. My name is Farhan Marzuki. My student ID is EC21091. Today, I would like to present about 40 bus system that I have created using ETAP simulations. So first of all, to create this circuit, I have used the template given in this ETAP simulation. So now I would like to explain about this project background, which is in this project, as a student, we need to construct a transmission system network for a load flow analysis and short circuit analysis by using Ieee 13 bus system. To make the system, the electrical transition analyzer program ETAP has been used in this project. So this software application that can construct and simulate the Ieee 14 bus. So by using this ETAP software, load flow analysis and short circuit analysis can be constructed. Therefore, after the network modeling is successfully modeled, fault analysis should be determined and the data need to be compared within the computer calculation from ETAP software and hand calculation. The fault analysis calculation needs to be determined from each bus. So the information for first of all, the information in this circuit is it has 14 bus bar, 3 generator, 1 power grid, 3 transformer, and 12 loads. So now I would like to run this load analysis circuit, load flow analysis circuit. So it will show some value. It will show the value and the circuit has been run. So I will explain about the result that have given in this circuit. So before that, load flow analysis is used to determine the problem occurring in the power system network or grid. There are 4 quantities in a system node that are classified as the voltage magnitude, which is phase angle, real, reactive power. And the bus and quantities are correlated with each other, and the bus are named as load bus, generator, and slack bus. Load flow can be calculated using 3 methods, which are Gauss-Seidel method, Newton-Raphson method, and fast-Dirichlet method. So now I will show the rating for each component. So this is the load flow analyzer. So the loads are this is the rating and the types that show for the load flow analysis. Next is the source, which is generator 1 to generator 3 to 2, generator 6 to 2, and others. So U2 is the power grid. So and this for the bus result. Here the voltage, the MW loadings. Next, I will show the summary result for this load flow analysis. So this is the summary of total generation, loading, and demand for load flow analysis. So it will show the source, swing bus, source not swing buses, total demand, total motor load, total static load, total constant I load, total generated load, apparent losses, system mismatch, number of iterations. So the value for each component. And next the bus loading summary report. We can see here the results, and we can check the value for our informations. And next, we also can see the load flow report on the report manager. Here the load flow reports, which is have 14 bus here, so we can double check it and get the value for the load flow, load voltage and others. Now we will check the error that we'll have in this circuit when we run it. So we just click the alert view, so it will show the result. So in this circuit, the error that will happen is over voltage, over excited, under power and under power. Now let's move on to the short circuit analysis. So first of all, the circuit analysis has been known also by the Ieee 14 bus system. A short circuit is defined as an unusual connection of very low impedance made internationally or unintentionally between 2 points of different potentials. So shunt faults are another name for short circuit fault. This fault occurs as a result and resultant failure between phase conductors or both. The short circuit has been divided to maximum and minimum short circuit currents. So first of all, we will check the short circuit study case. So as we can see here, we choose the all bus and made it to fault. So first of all, I will run the circuit in minimum phase. So the circuit has been run. So as we can see here, the circuit has shown the value for each component and for each bus bar. So we open the report manager and we check the summary. Here is the information and value that we should get for short circuit summary. Short circuit summary in minimum conditions. So here it will show the 14 bus bar, which is in 3-phase fault, line to ground fault, line to line fault, and line to line to ground. So it will give the different value to the maximum conditions. So now I will run the short circuit analysis to the maximum conditions. So it also have showed the value for each component as usual for the generator, the bus bar, and others component. We also can check the summary by tap the report manager. So this is the short circuit summary report for the maximum conditions. So it also have the same total of bus bar, which is 14, the same value for the 3-phase fault, line to ground fault, line to ground fault, and line to ground. So but it will show the different value from the minimum condition, which will be higher than the minimum conditions. So this report will give us the information to the each conditions. So we also must to check the value between minimum, maximum, and normal conditions that we must to calculate with the manual calculations, which is manual calculation. We must to choose one bus, which, for example, bus number 3, and we can get the value from the manual calculations. So the normal value that I get is between maximum and minimum value. So for conclusions, load flow and short circuit analysis. The conclusion is load flow and short circuit analysis are critical in the design of electrical power system, and these two types of analysis are used in this project to study system behavior and give recommendation for improvement. For example, short circuit analysis is essential to verify that the equipment is protected by protective device with interrupt ratings, and such as a circuit breaker and fuse. And if the current exceeds the interrupting rating, the effect is destructive. So for the load flow studies determine that whether or not system voltage remain within required limits during normal or emergency operation, as well as whether or not equipment such as transformer and cable overload. So load flow analysis also is the most important and required method for examining problems in power system operating and planning. So that's all from me. Thank you.